This computer. Okay. So today we're just working on yeah, as I was saying, we're gonna expand our knowledge on sweep, especially. And last time I was talking this concept about this concept called cross section, and I actually found a very useful command that it showcases this concept very clearly. Okay, so if you could all open the practice 3.3dm, it's in the Zoom chat, but I also sent it to everyone's email. And if you don't see it in the Zoom chat or your email, just feel free to send me a chat and then I'll send it again. But if everyone could just, how many people are here? 16. No, we're gonna give it 2 more minutes. Okay. Oops, sharing the wrong screen. And by the way, sorry, I can't remember everyone's name. So if you're new and you have Discord, you can join using this link here in the chat. This is just, oh, that's not the Discord link. Okay, copy that. My bad, that's a Zoom link. Okay. The second one is probably the most important. Hold up, my mic is disconnected. Give me a second. Okay, so it should go now, right? So as I was saying, sorry for the delay, the Discord, not the Discord, the meeting recording for our second class is also there. So if you have some spare time and you missed it, feel free to watch it. Okay, I think we're gonna start. Yeah, it's recording. Okay, so basically, what a cross section is, you can imagine that. Remember when we talked about? So let me zoom in. So if you could all just maybe go to this little box here with the weird shapes. If we go into and these shapes, you can see how they kind of, I made it intentionally, so they kind of get more complicated. So it starts from a box and then goes to like a cake, that's what I call it. And there's a tunnel, which is what we learned to we can use sweep 1 to make that. Which actually let's do a review on sweep before, since everyone might forget. Sweep, basically the title is it sort of explains what the command does, which is, well, you can imagine it as you're sweeping this curve, that curve right here, right? The one with all the dots. You're essentially sweeping this.
You aren't sharing the screen.
Oh, am I not? I'm so sorry. Okay. Thank you. Good catch. So we're essentially sweeping your cross section, which is this. Okay, along your railing like that, and thereby creating a poly surface. Like for example, let's start with a simple example. Let's say we have your circle here. So let me just make my railing. Let's cut this in half. Yes, actually, circle will be too boring. Let's do an intercurve. As such, like that. Oh, still kind of a circle, but like that. And then we're gonna make make a closed surface like that. And just for the sake of clarity, I'm gonna put text on it because it's okay. So that would be our rail. Rail will be .1, and your cross section, or what does the command call it? Sweep 1 rail. That's a rail, and it's called sweep shapes. Okay. So your sweep shape will be this one. And essentially what we're gonna do is you're gonna connect them because you're kind of using both of them, right? And then we're gonna move, say we have the shape and then, oh, not touching, let's do 90 degrees, rotate like that. And we're trying kind of to make this shape right here. But this is a uniform shape. And this is kind of like a very organic like shape. We're gonna move this. Make sure that you have all of your, the subtitle. Make sure you have all of these snaps on. So like snap, and then you have your end, near, point, mid. The first four are the most important. The others are kind of your preference. Then you can move your cross section onto your rilling or your sweep shape, sorry, like that. So if you zoom in, they should be touching each other. And then let me just move this here. That would be your sweep shape. And you can execute command sweep one. And we can just worry about sweep one for now. And there's also another one called sweep two, which basically is just double the cross section and double the rilling. But as long as you understand sweep one, so sweep, so you can select your rail, which is labeled here. And then we have your sweep shape, that one here. So click, gets highlighted, press enter when done. So when you press enter, you're gonna see this arrow. And I'm actually not sure what it is. It's kind of just where the pixels go. You don't have to worry about it. It's just there for you to check where the scene point is kind of at. And so we're gonna press enter again. And it's gonna give us kind of this option screen. And we can just click OK as such. And now you can see, essentially, you have the shape, right? You have your curve, which is our sweep shape or cross section, as I like to call it. You're basically rotating. You're kind of sweeping. You know what I mean? Like you have your shape, right? And then you're sweeping this along your railing. And at every point on the railing, it's rotating the shape like that. And it moves forward a bit and it rotates it again. And it basically kind of like whooshes along that rail and it creates this 3D surface shape. And this is mostly used for kind of, first, you can make a tunnel, but you could also make some pretty cool, I guess, very interesting like handles, like things that you hold. Think so. It's like if I have my like here, right? Like I have like a really weird cup here. You can kind of sweep, get your cross section. I don't know, maybe you could see that. You could get your cross sections like that, and this would be your railing, and you can sweep an entire cross section on the railing, and then you get this cool handle. Anyways, so that's sweep. Kind of looks like a handle or a tunnel. Anyone have any questions? Oh, hi, David, you're here. Am I recording? Oh, I am. Okay, cool. Well, that's sweep. And now we're gonna go on to skip off. Loft is okay. We're gonna go on to the practice 3. Okay, so this is our cross section demo. Or let me put another text. Or it's called, what is it called again? Sweep one. Sorry, I'm bad with names. Sweep shapes, yes. What are your sweep shapes? Sweep. That's very big. Okay. 5. Oh, okay. So your cross section or your sweep shaped. And basically, I got this really convenient command here. It's called clipping planes. And you'll see what it does in a second. Basically, you might say like it's just like a rectangle, right? But you have this extruding line here. And you notice, let's start with a simple box. So start from the beginning. Last time I explained it, it's a little confusing because I had to do all the extra commands and they were like really flashy. But with clipping plane, you can see that when you move this plane inwards, right? And then as it gets closer and closer to your box here, it kind of cuts it. And basically it's kind of like a portable split command. Basically it splits the box like that. And this should be pretty simple to understand because when you're cutting open a box, right? What would be the shape that you see? It would just be the same 2D shape all throughout, right? Because essentially they are this line here, this line here, right? This white line here is it's perpendicular, right? To all of your other lines. This means that your 2D shape or your cross section or your sweep shape is going to stay the same throughout the process of cutting it. Kind of like cutting a cake, like that. There, so now our box is gone. We can work on our cake here. And everyone's had a birthday, hopefully. And when you cut open a cake, right, you should see, well, how about we just, I know you don't cut a cake like that, but if we look at it from this perspective, you can see that it's also a rectangle, the cross section that is. And this is a very neat command because you get to see, no matter how complicated your project is, you get to see what, it's very interesting to see what the cross section looks like, right? And we can keep cutting it like that. And you can notice that essentially, if we look at it from this view, right? And move our plane somewhere closer, smaller. And the size of your plane doesn't really matter. It's the position of where it is. So if we look at it from like here, so we start from the beginning, you notice that even this is a circular shape, right? It doesn't resemble rectangle at all. But how come when you cut it, see the rectangle? So first there's like a really, really small, looks like a square. And it goes into a rectangle and it gets bigger and bigger until it reaches the middle point. And then it gets smaller and smaller as such, like that. So yeah, something to play around with. And knowing what your cross section is going to look like is very, very important when you go modeling. Because everything you make kind of originates from 2D lines, which is our cross section. So a good understanding of that would really help you in the future. And then let's move on to our tunnel, which this should be this should resemble of what we made over here. Because if we delete that, oops, if we delete this, well, I delete the curves as well. Really? Okay. Just do edge. This is just to duplicate the circle here. Let's delete our curve. I should just move it away. You can see that, let's assume that this is a perfect circle. When you use your clipping plane, which is this one here, you should also see that the circle, the cross section of that is tapped actually. The cross section of that resembles a circle. And the reason that is getting more and more, well, elliptical like that is because essentially the circle is adjusting based on your railing, which is the semicircle here. And as such, if we rotate the plane, yes, we can rotate it like that. And then we cut in here. At some point, we're gonna see a circle and then we can rotate it again like that. And we zoom in. So another circle. Yeah, so that's some interesting things you can play around with cross section. Okay, does anyone have any questions? No questions? Okay, cool. Hopefully everyone's getting this. And okay, let's move on to this shape. This is a 3D surface. And the difference between a 3D surface and a poly surface here, well, it's basically that this is one surface and this is multiple surface. That's really just the difference. And then you actually have cross sections for your 2D and 3D surfaces as well. They're essentially just a line, right? If we move the clipping plane over here, actually, let's move this. Oh, someone sent a chat. Someone said chip. Oh, does kind of look like a chip. I don't know how I made this. I think it's from twist, like a random intercurve, enclosed intercurve like that. So I made it, oops, okay, like that. I just twisted it. Like, okay, well, anyways, we're gonna move this actually in here. So it disappears. And you can basically see how if we, let's say we move in the clipping plane, like that. You see the cross section of that is just a line, right? It's kind of like a semicircle, not a semicircle, like a quarter of a circle. You know the universe is shaped like Pringles. Thank you, David. That's pretty cool. And then, okay. And then we have, as I was saying, we have a line as cross section. That, that. And notice how if we change the clipping plane like that, the cross section changes as well. This is because this is not a uniform shape. If it is a uniform shape, let's say we have a circle. Circle is kind of boring, and my circle is not working for some reason. Oh, that's because everything. Oh yeah, it gets a little confusing because you can think of this as making like like a really really large knife, and this is cutting like everything over here. That's why I see the circle appears now because it cut the circle away as well. So something to keep in mind. Yeah, don't make that mistake. And then we have our circle here, and we have a planar surface. So we have a 2D surface versus a 3D surface. You can see that the lines, they're a lot less dense. So they're really spaced apart. This means this is basically pixels. You can think of it as like this is 4 pixels. So 1, 2, 3, 4. This is like a lot of pixels. So this is more complicated shape. Plus it's 3D. And so we have let's use the clipping plane on the 2D. And you can see that if we move this closer and closer to the 2D plane, the cross section actually turns into a line like that. And just it's very similar to this. Let me move this outward to your cake, because for your cake, essentially your cross section gets the rectangle here. It gets larger and larger, and eventually it reaches maximum, right? And it gets smaller and smaller. So that's how a circle would work. So very similar. This just gets the line gets longer and longer, and see maximum, and it decreases like that. Okay, that 2D shape, 3D shape, cross sections. I'm just trying to be really thorough here. So let's get rid of the burrito or chip. That. And now we have this vase here, which already got kind of cut, but it's okay. So when we move this clipping plane in, we can see that this is a really complicated cross section, right? So essentially you have kind of it's just a 2D. Yeah, you have your line or slash shape here, and we can actually can we do patch? Oh, we cannot. This is a clipping plane. But you can see that there's like kind of like this diamond shape. And on the top, there's like this V shape. Bottom, there's another, just like an upside down V. So that is what I would think like to be like a really complicated cross section. And surprisingly, when you make, actually not surprising, it's kind of common sense. When you want to make a base like that, you don't use the cross sections by the size. And what I mean by that is if we get rid of the chips here again, that you can see how this shape is actually kind of complicated. Plus, the problem with this is that it kind of changes at every point that we move our clipping plane. This is the reason we look at it at a different perspective, which is we can, and this line here basically just is that this is the direction. How do I don't know. This is like, you don't really cut the things on the line side basically, and everything on here is cut. And what we can do, we can send the line facing downwards. So rotate it 90 degrees. Actually, that's not good. 180 degrees. Now the line is downwards. We move the thing up. Okay. And now you can see how that when we move the clipping plane downwards, you can see how all the cross sections are just circles. And this is a really bad base that I made probably when I was like in grade 8, but it works, it works. You can see that these are all circles. Oh, assume they're circles. They're not actually not circles. Hold up, let me get a new better base club. Interesting. Do I have a better one? Actually, it doesn't matter. Let's just go back to this one here. And let's look at it like let's do a Starbucks cup. Let's do simplify things a bit. So it's like a tiny bit bigger on the top side. Okay, we'll just loft it. Disappeared because our clipping plane. We can loft these two curves. All right, so that's our cup. Oh, it's a little too big. But anyways, that will be our cup. Get rid of the lines. And basically, you have your clipping plane, and you can notice that even if we, let's say, so we use that, right? Even with a simple shape like that, the side cross section is kind of complicated like that. So you can see that it's like first starts off with a V and then two lines. See, and then it should return back to the V like that. V, line, V, like that. And that would be a little too complicated to model that. And when we're modeling, we always try to start from the basic cross sections, which is why if you can see, I started with two circles and lofted them together. This is because in my mind, I kind of imagined them as two circles since you have, if you use a clipping plane, see when it's moving downwards, all you see is circles. That's actually all you see. It's just the circle is constantly getting smaller and smaller and smaller until it reaches your bottom, the size of your base. Yeah, so with the base, I'm gonna talk about that maybe after I do all of these introductions. And you should be able to find this file and send it again because Zoom sucks. Zoom, practice 3. Okay, there we go. Okay, does anyone have any questions with cross sections? I'm just gonna put everything back. Okay, there we go. Anyone have any questions or concerns or anything? Okay, going once. Okay, I'm gonna skip to should do patch. Okay, and you can see how I got them neatly labeled, and there's like a template for you as well. So move mirror here because we're in more space. Okay, so we have patch, and if you remember from our second meeting, we can briefly recall, hopefully, that there's this very, very, very useful command called planar surf or planar surface, which basically means 2D surface from a curve. And essentially what you have to do, you need to have a 2D surface and it needs to be close. Then you enter planar surface, enter planar surface, select the curves that you want to build the surface on. So in this case, this one, but I digress. I'm gonna move this a little further on. So planar surf, enter. So select planar surface to build surface that would be the surface. And then we're gonna press enter. You can see we created a surface, a 2D surface. Then you might ask, what would happen if we have a 3D surface like that, which can be created by either by going in perspective mode and turning off this option here, but we're currently just gonna work with control points. And hopefully everyone remembers control points. For control points, we have, let's say we have a curve like that. And the more points it has, the more complicated it's gonna be. Notice how I click a lot of times on here. That's why it's like kind of not smooth. And then we learned on our first class actually that you can move your control points as such. So maybe put this out like that, and then I don't know, adjust your shape that. But we could also move the point up, which means doing this and that. Now, if you look at it from the side, you're gonna see a line. So a straight line like that, because everything else is 2D, right? But then you're gonna have two extrusions, so like two mountains like that. That's how you make a 3D curve. So as you can see, I created here, these are less complicated shapes. And when you use planar surface on either one of these 3D curves, you're going to get an error. We mentioned this before. However, if you do want to make a surface using 3D curves, there's this very convenient command called patch, kind of like a eye patch. You patch stuff, the patch. And when you enter the command, it's the same as planar surface. And it asks you to select your curve, and then you press your enter key. And the different part is that you have your options screen again, but we're not going to worry about that. Actually, we might talk about UV spans, but for now, we're just going to click OK. And now you can see it didn't give us an error. Instead, it gave us a surface like that. Okay. So that basically is planar surface in 3D. And if we go back to the option screen, because what happens when you have a very kind of not so complicated shape like that, the computer actually, it might change the shape based on how complicated you want it to be. And what I mean by that is if you use patch, again, on the same thing, I just copied and pasted it over here. Click this curve, press enter. If we change the UV span, so let's say instead of 10, let's exaggerate it, let's make it 100 by 100. And this is just your kind of like your pixels or the amount of lines that appear on your 3D curve, on your 3D surface. So, and then don't worry about the rest. So if you click OK, 100 might be too much. I'm gonna cancel that. We're gonna do 50. That's just do 40. Don't want it to crash. 40 by 40. Okay. And you can see there are a lot more lines as such. See? Well, obviously you can tell there are more long lines, but I also feel like the surface is smoother, but it's just me. You really start to see a difference when you make something like, let's delete this. Oops, not the curve. Let's copy the curve over here. Delete this one here. So we're gonna start from, we're gonna patch again, but this time we're gonna do like, I don't know, one by one. So what will happen? Actually, nothing happens. It's like the same curve. This is a very simple shape. That's why it's not showing that much. Oh, actually, oh, never mind. That's just because it's touching the base one. But yeah, so you can adjust the amount of UVs on that. And they really just kind of look the same. It's been rendered. You can see that there's not much of a difference. And more complicated shapes don't always mean better because, well, they take up more file size and blah, blah, blah. But let's go to this shape here. Let's try patch. I reckon this will be a little different. So click this curve here, enter, and we're not gonna do one by one. We're gonna do like 20 by 20. 20 by 20, okay. And you can see it didn't give us an error. Instead, it created this shape that, yeah, it kind of matches. Oh, I remember now. The more kind of like the more UVs you have, I think it matches your curve more perfectly. That's the upside to having more pixels. Yeah, so you have your 3D curve. And to render it, actually looks pretty nice, like another chip, right? That. Okay. All right. So that's patch. And you feel free to just play around with this because you get all these control points yourself, right? You can have adjust it like that. Then you can also patch it. Patch. That did not work. Okay, maybe too complicated shape. Yeah, so just play around with the command because patch is actually really powerful. As you can see here, that it's not limited to your 2D surface. Okay, so that's patch. I would say that's probably like I don't know, whatever, doesn't matter. Let's go to mirror. I forgot what I was gonna say. So mirror is really, really simple. You can see that I have a box and two lines here. For mirror, you type the command, first you need to select an object to mirror. And in this case, it's this box. And enter when done. And your mirror plane. And if you've all learned, there's this what is it called? It's like there's a certain type of shape that if you kind of cut it in half, oh, symmetrical, of course. You have your symmetrical shapes. And basically, I don't know if I have an example here. I guess like an AirPod case like that, it's kind of symmetrical. You can cut it through the middle, and you would have obviously the same things, except the letters, but you would have the same thing on actually this is a good example. Actually, it is not. Like if you think of a star, you can cut it. There's no command to make star, but you can imagine what a star looks like. Cut it in half. It's going to be the left and right are going to be symmetrical. Well, this is essentially the idea of mirror. When you type mirror, object in mirror, the box enter, start of your mirror plane. Let's say it's from here to here. So just according to our line here, right? Let's get rid of this one. And basically you can see that Rhino created a new box for you based on this mirror plane, the line, which is the line here. And you don't have to make a line beforehand. It's just there for the reference. Basically you can, the computer makes it so that the distance like that. So the two lines, this one and this one, these two, they should be the same lines. As well as if you make a line like here, right? From here to actually perpendicular to here. You should be able to copy, so copy. So start from this point and copy it all the way over here. And the corner should match as such. Let me select the curve as such, right? So that's basically mirror command. And you don't have to feel limited to just, mirroring a box. The most useful part about mirror is that it saves a lot of trouble. And what I mean by that is, I actually have a good demo here. Just give me a second. Got chest. Made like this treasure chest here. For club, David should remember because it was my club. And then it's opening. And all we had to do, right? You can see it's a very simple, I had a reference picture here, but it's very simple. Essentially, you have, I don't know how we can. So we're trying to make this chest, and it kind of looks pretty cool. I just want to show you guys. Did I render it? Yeah, I rendered it. See, like it has all the textures. We're gonna learn how to do that later. But basically, notice how I made these chests. The outlines of the chest, they're essentially the same. And they're like kind of like what I talked about, like symmetrical shapes, which means that when you draw something from here, you draw a line, that's not a line, polyline, from like here, actually, let me just use my cursor, from here to here, if that's my line, right? You see that the shape is perfectly symmetrical. This means that once you have made this poly surface here, you don't even have to make another one. You just have to mirror it. So let's say, oh no, I lost all these like that. This is not a prepared demonstration, which is there. So, oh, it's surface overlap, but it's fine. So ignore the blinking thing. So let's say I've successfully made my outline, the gold, the gold outlines. I just have to mirror that. And the start of mirror plane, you just have to find it, right? But it should be somewhere like here. If you just select this reference point. Yeah, and then hold down shift to make it perpendicular. Like that. And click, and then you can see it basically copied the exact same replica along the axis. And if you didn't see that, I'll do it again. So mirror. Your mirror plane is from here to here. Like that is a very short mirror plane, I know. You could also extend it, but it doesn't really matter as long as it's a line that lies somewhere along your shape. It's gonna work. And in this case, since the distance between, so I drew a line here, right? Just for your reference. So my line is like from here to here. That is my line. Since the distance between the line and my shape is 0, this means that the object that it mirrored and the object that I originally had. So let's say, if you can all look at my camera, let's assume that these are two exact pens. So you have one here, and then let's say we make a mirror plane, like my hand is my mirror plane, right? Basically, it's gonna mirror exactly like that. So there's gonna be two that are spaced apart, and you can assume my hand is in the middle. But since in here, if you could all go back to my screen, since in here, the mirror plane is like the exact is like it's exactly touching your first shape. This means, assume this piece of paper, that's my mirror plane. It's kind of like touching. This means that your second shape or your mirrored shape is going to be touching as well. Like that. Like that. Okay, and then we remove the paper. And now you have two pens touching. That's what I mean. Sorry if it was a little confusing. You can mirror this over like that. You don't have to press enter actually. Pretty neat. And now you have these two. And why would we bother, right? To make another one when we could just mirror like that. And I think I forgot to, ooh, okay, probably, that's fine. Forgot to close these in, but it's fine. We have these, you get the idea. We're gonna mirror it again. And this time we're gonna find a good axis, which is say somewhere here. Here and here. So that will be our mirror axis. And since everything that I created lines up with your x-axis, this means that this is perfectly straight. So we can just do a little bit of your mirror plane like that. Click. Now I made a shape. So that's mirror. And this also shows us, so the fact that I'm able to mirror everything shows how important actually the snap commands are. Because if I don't have these snaps on, who knows, my shape might be a little, twisted that way, twisted this way. This is why you always snap on your edges or your middle points or your whatever, your 3D edges things, and make sure that it lines up with your axis. It doesn't actually have to line up as long as the shape lines up. It doesn't have to line up with the axis, so I can create it like that. That's totally fine. But you gotta make sure that if you're making I would say this is a pretty strict shape because it has all of these geometrical shapes. Like you have your circles, you have your lines, you have rectangles, right? This will be pretty, like snap commands will be required on this because, it's a chess. If you were to make something like, I don't know, I'm just grabbing random objects around me. If you want to make something like that, the base of this light, if you can see, how's my camera? Can you see? Yeah, if you were to make like that, and then notice how there's like an opening here, you wouldn't need snap commands as much as you would need in this, because I would say this is kind of a sharp, because you see all of these sharp lines. Whereas this one, very soft. You have these, man, sorry for the light. You have these like opening curves that are not so sharp. Ooh, how do I close this? Okay. All right, so that's mirror. It's surprisingly useful. And then I believe we should take a break because it's almost 6:15. So I guess we'll take a 10-minute break this time, and then I'll see you guys at 6:24. Okay. So enjoy your break. Maybe don't look at your screen. And then put up a timer. Go 10 minutes. Okay. All right, so that was our break. Okay, and now we're gonna continue to our. I'll give a few seconds for everyone to come back. Okay, I'm still screen sharing. Oh, actually, it's the wrong screen. I share my entire screen. No, that's the other part. This is the chest. So yeah, so we do mirror before the break. And now we're gonna move on to this command called flow/flow along surface. And these are essentially the same command, except one is in 2D and one is in 3D. Okay. And okay, someone back. If you're back, can you just actually it's fine. This is okay. So what is flow? Flow basically you have you have your, let's see, we can see that in this template here. You have a bunch of circles, right? And we have this line. If we do the command flow, I always find that it's actually harder to explain the command than to just actually execute it. So I'm gonna do the command first and then explain it. Basically, when you execute flow, you're asked to select objects to flow along a curve. So in this case, your object, we're gonna select all of these circles over here, like that. So press enter when done. After we select all the circles, we're gonna press enter. So your base curve, essentially what it is that you only need to select it near one end for some reason, but this would be our base curve, and we can just click it, that it's selected, and make sure that you're selecting near end. This means that I selected this end, and now that my target curve, you're selecting it near the matching end, which if we translate it over here, you can see that when we click it, but oh, this is basically what happens, except I need to modify this a little bit so that, sorry, I didn't test the templates before I made them. That's why they're a little not very assuring. So let's do the flow again. Select all of your objects, these circles, press enter. Your base curve going to be here, click. Target curve matching end is here. So click. Okay, and now you can see, well, in contrast, right, to these circles, since this is a straight line and this is a curve, what flow does, it basically kind of adjusts your circles based on what your line looks like. And we can understand that better by using another example, but not this one, because this one is a little too complicated and the command might not execute. So we're gonna do like kind of a semicircle, like that. We're gonna do this, and we're gonna use flow again. Okay. Your objects, these circles, enter, base curve, one end, this end, and we translate it to this end. And now you can see that your circles have been, well, slightly modified, because you can see that this one is a little stretched as you can see here. And then also have, so they vary in size. And also there's this specific pattern because it follows the original curve. So the distance here, so if I draw a line from here to here, perpendicular like that, they should be somewhat similar. So this line should be about the same as this line here. Somewhere like that. That's not a perfect line, because so something like that. these would be pretty similar. You're essentially, well, the command is called flow because you're flowing these 5 circular shapes along your railing or your line. And we could actually try it just for fun. Like you could flow, again, doing the same thing for practice, I guess, enter base curve this end and target curves this end. And you can see that this is relatively straight, so it kind of has that circular, still has a circular shape. But however, it kind of goes crazy from here because you see this very, very sharp turn. And this causes your shape to get stretched out so much that it kind of overlaps that. And then this returns because this part is straight. Okay, so that's flow. And you don't have to do circles. You could do any shape. So for example, just undo all the circles. So we still have these. Let's keep this shape. Or we can just make another one. Let's make another semicircle. Have that there. Well, not a semicircle, but we could make other things. For example, we could make one big circle. Actually, let's make
Huh?
2 big
Yeah.
circles like that. So there's one, another one. Does someone have a question? Probably not. Okay, so 2. Well, I don't know why I'm calling it a circle. It's kind of more like a random shape. But if we have 2 of these, right, we can use flow objects flowing along the curve. And you want to keep, the reason this is straight is because it's relatively easy to keep track of. And you're gonna see that you're gonna see that a lot when we move into the 3D. So you would want to keep your, what's it called? Reference line, reference curve, relatively simple. Because you wouldn't want to have a very, very curvy reference line. Then you wouldn't actually, your measurements after you flow wouldn't, okay, a very big yawn. Hello, Kevin. Oh,
没什么。
you okay? Like, that was, I don't think I've ever, okay, I'm sorry. Okay, well, he moved. Okay, all right. Anyways, he's enjoying this class, and then we're gonna back to flow, right? Flow. Select objects to flow along a curve. So you have your objects, 2 objects, enter, and you have your base curve. Select near this end. And just repeating the same thing, your target curve. We're gonna move to this here. And you can, oops, like that. You can see how it still stays relatively the same. So this and that, and then it got a lot more complicated. So because we can judge from the control points. In this case, it has only like 6 control points. And this has a lot, and they all lie on the surface, which means that if you try to move one, it's actually kind of hard because you get this random shape. So yeah, so it gets, now we know that flow makes your end product very complicated. And this isn't even a complicated surface. It's just like, what, 5 control points, the intercurve. So, right. That's a kind of a basic introduction to flow. And what else can we do? You could also do 3D. You don't, the reason that this is called flow is called 2D and flow along surface is called 3D is because flow along surface, you're working with like these surfaces here, and you could do any kind of surfaces. However, in flow, there's also a, you could also do surfaces or poly surfaces. So like, so we have that. We have our box and we have a relatively smaller one. That kind of Minecraft. Okay, so we have that. We have our 4 boxes, right? And right now they're very, very, very strict boxes. They're like boxes, so they're means they're very geometric. However, if we try to flow it, you can kind of predict the end result based on what we've seen with all the circles and the puddle shapes. So flow, select objects to flow along a curve. So these four, enter. Base curve, select one end, so it would be this end. And target curve, same thing here. And you can see, essentially, all of your boxes, they turn into like super complicated shapes, right? Essentially, you just twisted them along your target curve, like that. And even this one, you can see that it's slightly bent. That. So that's pretty cool. You can be kind of like, I don't know, kind of like the matrix. I don't know. You can make buildings. Let's assume these are like buildings. You can make them change based on your target curve. So that's really interesting. And I used an example of boxes here. You could try other things like circles or even organic shapes to make them more organic. In this case, I was making geometrical shapes like organic. Like that, see? Yeah, so that's flow. And just a cool thing that I wanted to show is let's make a another curve because the circle shape is kind of getting boring. Let's try this. That. Okay, do flow again. And you're going to play this on your own computer. Base curve, that, just to see how it looks. Does this work? Oh, it did not work. Okay, how about that's because this kind of curving too much inwards. So just control point out. So that's a convenience of control points. So actually, let's go back. Let's go back to this because it looks better. Assume we have these, and just for the sake of, let's move a little closer. Okay. Basically, this is a really cool thing. And before you use any command, this is just a flow because flow is a good example. If you go down here, and for Mac, I don't think you have it. You can check. If you go past the grid snap and OSnap and smart track and gumball and stuff, you see this place called record history. And next to it, you have like constantly changing text that tells you your whatever CPU you use and stuff. If you click on this record history, it's gonna turn blue and it's gonna get, the letters are gonna get bolded, right? And now, while this is highlighted, we can type flow and select your objects. Enter. So the same thing, essentially. Base curve, target curve, that. So you get this. It's about the same thing. However, since we clicked record history, this allows us to kind of just adjust our curve. And what I mean by that is this is our target curve, right? And right now it's like a kind of like a circle, organic shape circle. You click on this control point and you can drag it in like that. And you can see that your shape changes because essentially after you do record history, everything that you do, the computer is going to repeat our last command, which is flow. So this is just some really cool things that you could do. So we could change it back like that. And you can see, oh, they kind of return to normal. And then we can also do things like you can move this inwards like that and select this control point. We could just reverse it. Actually, this is probably not a good idea, but yeah, you can see why. And we have that. Yeah, so you could do anything that you want with this curve, and the shapes will adjust based on the curve shape. And if I were to have a more complicated curve, one with more control points, you can get much more complicated results like that. Actually, I wouldn't stretch it too much, so like if you shorten it as such, oh, they kind of overlap. So yeah, so you can play around with it. Except record history is actually if you work with really complicated shapes, it might crash your computer. So just start with simple shapes and play around. So that is flow, just regular flow 2D. Let's keep this for the template. Okay, so that's flow 2D. And before we move on to flow along surface, I would like to do a kind of a brief review on trimming and splitting. Okay, and basically trim and split are just cutting commands through this. And last time we talked, so let me just borrow this over here. Okay, last time we talked that if we have you have a box here and you want to cut it in half. Essentially, the way I like to do it, just get the mid. Let's say we want to cut it exactly in half. You just have to get a knife and cut it in half using the split command, extrude. So now we have made a line. If we use extrude curve, you're going to extrude this line. Let's do it downwards. So now you have a plane intersecting your box, right? This should be review. And you can move it as such. Actually, make your knife a bit larger. Your knife a bit larger, like that. So that is covering all of the box. Then you would type split. Select your objects to split. That would be the thing, that would be the cake that's being cut. So you select this. You press enter. Select cutting object, that's the knife. Select the plane that you just made. Enter. Now if we get rid of the knife, you can see that it's been cut in half, like that. So this is pretty simple stuff. And another way to make it the knife, right? You don't have to type extrude curve actually, because this is just for exact measurement. If you were to split something, all you have to do is have, first of all, have gumball turned on. So you have all these arrows. And you can see that in addition to this blue arrow, there's this kind of circular shape. And when you hover over it, it turns black. Basically, this is the extrude shortcut. And what you can do, so similar to how we drag the arrow up and down, like that, you can also drag the blue circle. And if you drag it down, it essentially just extrudes the line that you have, makes it into a surface. So that's a shortcut that you can remember. It saves a bit of time. Okay, so that's introduction to the split. And you could also you don't have to split this in half. So for example, if we have our knife here, right, you can adjust our knife. Let's make it smaller like that. Oops. Like that, and we can rotate it. Let's say we want it like these, and something like that, and we can move it outwards. So that, just make sure that it's intersecting the whole thing, because if you cut it and slide it in like that, as such, it's not going to make an opening, because when you execute split, select your objects, this one, knife, it's the same, enter. So splitting would fail, because essentially it's not intersecting the full thing. This means that we have to keep going. We have to move this here. This should be pretty good. So now you can see that your knife here has cut the edge of your box. I think I did something. Oh, you mean you did something in Rhino? Okay. That's pretty cool. Do you want to show us? Oh yeah, and if you have any questions, just ask in the chat. It's totally fine. Okay, and then, so while we're waiting for an answer, I'm gonna keep going with this. So we're gonna split. Because we know that we can split, because we are able to split, because essentially this knife is cutting like a little bit of your box. And if we use split object to split the box, enter, look at your command bar, cutting objects. Actually, yeah, oops, sorry. Objects to split, to click the box, enter, your cutting object is the knife. Sure. And now you can see that this little prism piece has been cut off. You can just delete it with the knife as well. And there's an opening here. So that's how you make a cut like that. And if you want to cap this off, right? You could, if you don't want it, if you don't want to see the inside, one way to do this is to draw a curve like that. So I essentially just drew a triangle. And this is actually a 2D triangle. It just rotated in the 3D direction. Then we know that we're able, since this is 2D, I mean, you don't have to know for sure, because if it is, it's going to work like that. And if it's not, it's going to give you an error. So you should always try planar surface. And if planar surface doesn't work, remember we learned patch here. Oh, is this a patch? Yeah, this is a patch. So shiny. This is the patch. And then we can, yeah, so patch would work on 3D curves. And if we go to render, it doesn't really matter if the lines aren't lining up. So ideally, you might want to see like line here and then line connecting here. But if you go to render, which basically means that just putting it in a light, in the place was light, right? That has shades. So notice how this part is darker. This part is like slightly dark, and the top is very, very bright. And we know that the sun is coming somewhere from here, actually somewhere from here. How's this? Yeah, we know like the sun is coming somewhere from here. Yeah, so that's render. You can also play around with render. Just make sure you don't render too complicated objects. Okay, what was that? Yeah, so that's split, and you can do a lot more. The split is like it's a really split. It's a really, really universal command. Essentially, if we look at this plane here, just grab a painting. If you look at this plane here, it has 3 circles, different sizes on it. We can use split, and you're cutting objects. Oh, selected the cutting object. Oh, because I accidentally selected the base surface, the dark gray surface here. So we're gonna make sure we're not selecting anything. We're gonna type split. Enter your objects to split, which is, in this case, we're gonna split the surface because we wanna make cheese, like we wanna cut holes in it. And then so objects to split, enter, select cutting objects. Cutting objects are the knives. And in this case, it's this, that, enter, we'll turn darker. And now you can see that over here in the command bar, it says one surface split into 4 pieces and creating meshes, blah, blah, blah. And now we know that there's 4 pieces. We delete, actually we shouldn't delete. So there's 1, 2, 3, 4 pieces. If we delete the outer piece, we can see 3 surfaces, but that's not what we want because we want to cut holes. There you go. So that's split. And notice how after you split, right? So I just redid the split. After you split, you still have these 4 surfaces that you could delete freely, or you can maybe move them around and do some other things with them. Like for example, you can like, I don't know, like, okay, something cool that you can do, right? Just rotate it like that. So it creates like a half opening. This could be like, you know, like those garbage cans. Actually, I have one right there that like rotates, so like that, based on, so you throw garbage in it and then it rotates and you can close it back on, something like that. Cool, you can make just simple concepts. But what if you don't want it? What if you're, let's say, you're making a lot more, right? Curves. And what I mean by that, so let's make small circles. Oh, that's not on the, okay, anyways. So let's copy and paste a few more in it. As such, like that, and copy paste. What if you don't want the curvature, the surfaces to remain there? And this means, oh, that's a bad idea. Okay, I'm gonna delete this, delete all of these, and make a new surface because I accidentally cut through the thing. Okay, let's make this larger. That, okay. Primary surface, this. So we could use split command to cut more holes in it, right? But that would be too much work. That would be a lot more work than we would need to do, right? Because we have to individually delete everything goes circular surface, so that there would be holes. See? And this is where trim comes in, and TRIM is kind of like when you trim a paper, right? You have your scissor and you have a piece of paper and you trim it, right? Well, you might ask, like, that's the same thing as split. There's actually a slight difference. If we type trim, and when you're learning a new command, always keep an eye on what the command bar tells you to do, because it might be different, right? Even though trim and split are kind of the same. And in this case, they are different, because like for split, if you remember, oops, not split, split. Split, it asks you to select your objects to split, which I like to call it the cake, because you're using a knife and you're cutting the cake. However, in this case, if you type trim, okay, I am, select, it asks you to select the cutting object immediately, which is your knife. And in this case, we're going to select all of the circles. So curve Actually, one way to select it, you can just drag a window like that. And this is called, I forgot what it's called, but there's actually a very, very big difference. Basically, if you drag left to right, it's going to select every object that is entirely in the window. So in this case, if I just simply want to select the circle, right, I can click on it. But for the sake of the demonstration, we can drag on the circle and notice how this circle here is being partially selected, but not entirely. This is why only this circle will be selected. However, there's another type of selection, and notice how left to right, so left top to right, you can see right, left, right, that's your left, okay. From left to right, the lines of your box, so the kind of the blue shade, there's an outline, the lines are solid lines. This basically indicates what I've just said, everything that's entirely surrounded will be selected like that, and everything that's partially selected will not be selected. However, there's another one which is right to left. So this one, and you'll notice immediately how the lines around your box are dotted. This basically means that everything that's partially selected is going to be selected. I know it's kind of confusing. You don't have to know this, or you can just click everything. But so see how my box, sorry, my circle here, it's like it just teeny tiny bit selected, but it still gets highlighted. So that's the difference. And in this case, we just want to do our traditional selections like that to make sure, and our bottom rectangular plane is not going to get selected. I said select too many times, but anyways, so you can see that all of these are selected. And now we just have to go to trim, select our cutting objects. So all the circles, enter, and immediately it just asks us to select object to trim. So this is really, really convenient because for split, you have to select that, select this, split and delete everything. However, for trim, you can just click on the circles. See like that. It's actually kind of fun. You click on it and it cuts the hole because essentially it recognizes your circles. Let me just go back. It recognizes these circles as your knife. So whatever it is that you click, it's going to get deleted like that. And you don't have to do the inside, but also do the outside as such like that. Okay, so that's trim. And if we go back, pick another plane here just to show you how trim works. So we have our line here. We're using the extrude curve shortcut. So like that. And now we're going to rotate it a bit this way, wrong way. Where's my plane? Which way is it? Actually, it's like both ways. Whatever, it's fine. Just make this a little larger. Oh, there we go. So assume that we have a knife here. So again, it's like the same thing. It's just different sizes. We can also use trim. And your cutting object, which is your knife, you can click that, this plane here, enter, and select object to trim. Just click the corner and it's gonna get cut off. Yeah, so there's a very, very minor difference between trim and split. And there are some circumstances where you want to use trim and don't want to use split. But we'll be able to figure it out once we go. Oh, trim? Is it trim or split? The war between trim users and split users, I guess. I do feel trim is a lot more convenient though. Okay. So another thing with trim is actually I'm not gonna go into that because it's very not very useful and it might confuse a lot of people. Okay, but basically, where did my 3D surface go? Oh, there it is. Okay, so we're gonna use our cheese template once again. Delete all of these. And now if you hopefully you do not forget everything about flow, which is the command that flows your shapes along this axis. Now we're going to move into flow along surface. So in this case, we are going to type flow along surface, along surf, enter. Select the objects to flow along the surface. And we just have to click all of the circles, just multi-select them like that. So all of these are selected, press enter. And remember when we had a a curve, so this straight line over here, and you had to select near a corner. In this case, you just have to select your base surface, which is this one, near a corner. That, and we don't really have to worry about the corner for now. It's just there for reference. So in case, I don't know, you have a circle here and you have a rectangle here, and you somehow want the circle to end up on the left side and the rectangle on the other side. This is where the corners would actually matter because you don't want your shape to be flipped. So now we've selected your base surface. We're going to move on to the target surface, which is this very shiny shape that I made here. And we're going to just click it on this. So when you click it, notice how it blinks. And then you have all of these cool shapes reflected onto your surface from your rectangular surface. And remember when I said to keep things simple, this is why. Because when you start with a simple thing, you kind of just know all the dimensions. Whereas if you start with this, right, you're not gonna, first of all, it's very, very easy to start with a 2D plane and reflect them onto a 3D plane because you know that the curves are going to end up exactly on top of your surface. And this brings me to my my next thing. So now we have these circles, right, that are overlapping on top of the surface. Remember when we learned split or trim, we can basically, type trim, select your cutting objects. So enter. This is because I want to cut cheese holes in the surface here. So I selected all my circles. Now I can press enter. Press enter and select your objects to trim, which is this one. You can just select all of them. It's really fun. Like none, that, zoom in. Oops. That, and you can select that. So now you have a very, very shiny and cool flowy shape with holes in it. And this is essentially, this is very, very convenient because you're gonna know what the pattern is here, and you can just simply reflect it on whatever shape that you have. And this is one of the most convenient ways as well, because if you want, let's say I want to make a circle here, I'm not able to just grab the circle command here, or if I type circle, I cannot type. If I just type circle, center of circle here, and if I want to make a surface that, notice how it just disappears and ends up on the bottom. So working without flow along surf when you're trying to reflect something, it's very difficult. This is why this is a really good command. Like, for example, you could also do this like that, and then you could do all the things that, surface modeling commands that you do, and have that. This might work. I think this will work. So if you want to make this your cutting object, enter, you could trim this, even though this is not on your surface. However, oh yeah, that's the difference, main difference, sorry, forgot. Basically, you can notice how, see this curve isn't exactly on your surface, but you're still able to, to trim a part off like that. And actually, let me just test something out here. Oh, it does not. So it basically just makes a perpendicular line from, oops, from like here to your surface, see perpendicular, and then just cuts off your surface. However, with split, you're actually not able to split this. If I type split, object to split would be your surface, and enter cutting object is your circle. So enter, oh, it did split. Okay, I guess they both work now. Very awkward, but anyways, split trim, very convenient and cool command. And also you have flow along surface, which is also a very important command when you're making, let's see, gonna make one last example here. When you're, let's say, actually you can't really see this. Give me 1 second, sorry. When you want to make a, can you see this? Hold up, let me turn my camera. Oh yeah, you can see this. So when you want to make like, the cup again, the one that we had a tunnel thing. When you want to make patterns like that, since this is a circular shape, right? You're actually not able to just model it directly. What you actually have to do is to model this pattern. So in this case, it's like I'll just do a really brief exact, like a sketch of it. So in this case, my cup kind of looks like that. So we have a circle. Let's assume this is my cup. And I know we're kind of running out of time here. This will be the last thing that we do. Let's say this is my cup. Okay. That's our cup. And essentially we have our pattern. But if we try to model it like that, so it's kind of like a diamond shapes like that. It actually ends up like this. So we're not able to just draw a diamond on it. Basically, what we have to do is just copy or paste. We need a base plane. And this would change depending on whatever the shape it is. But for now, we can actually draw a diamond shape. So let's say like from here to here to here to here. And we can change the scale of it after, which means this is one curve. We can actually adjust it like that. And then we can basically just, I don't know what it looks like. Kind of, they're also like weird squiggly lines. But if we were to just make this diamond, let's give it thickness. Offset surf, oops, not offset. Offset surface is also a useful command that we're going to learn later. Basically, it gives your things thickness. So in this case, like that. And let's say this is our shape, right? And okay, so it looks something like that. And there's also the, like a little longer. I'm gonna make this much more longer because we only want one of these. Essentially, you can think of this as your cylinder is unfolding. So if you've ever played with like a paper, this is my AP homework, but it's fine. So you have like, this is our cup, right? See? Yeah, and essentially we're just unfolding it into a paper. So that's all we're doing. We have, if you could just go back to my screen, we have our cylinder here and we're unfolding it into a plane of paper, and we can use flow along surf. I'm not sure the scale would work, but you get the idea. Flow along. Select objects to flow along the surface, which is this very nice diamond. Actually, just a cube, but like rotated, but it's fine. Call it diamond. Enter your object. So enter base surface. It will be this one, and target surface doesn't really matter. So, oh, in this case, you can see that it's a little too long. So all we have to do is just scale it down a bit. Repeat the command. Oops, why is it like that? Okay, and get a satisfying result. Something like that. It's a little longer like that. Actually pretty cool. Flow along surface. Select object. This will be the object. Enter target surface. That. Oh, it went inwards. That's very sad. But essentially, you get the idea. Did it go inward? Oh, it did. Actually, it's fine. We can just move it out. Like that. Very cool. So that is how you can make these. So I would regard this as actually a pretty complicated shape because you're not able to just draw lines along your cup and make the shape. So yeah, so that's flow along serve and its basic application and my weird cup over here. So yeah, that's the last thing that we're gonna do for today. And does anyone have any questions before we end? Oh. Okay, so if no one has any questions, we're going to end right now and stop recording.